Hi there. Today we are going to see linear regression implementation in Python using Google Colab. And in this program, I'm not going to use any scientific library. Without using any scientific library, I will demonstrate you linear regression. So for that purpose, we have one problem. Suppose a univariate. This is going to be the univariate implementation of linear regression. So there is a variable called as age, and there is a salary. So suppose one company having employees which is having a different age criteria, age group, and they have a salary, some fixed salary based on their age. So because I'm not going to import any data from outside, so we are going to create our own data. So for that purpose, let's create our data first. So suppose that data set is having uh, let's see a data set. Okay, data set is equal to, there will be list containing the dictionary which is having first variable age as age, and the age which is having 25, comma, the next will be salary. So salary which is having, it is in 1000k, we can understand, so I'm writing directly in 35. It's a 35k, so 35 means 35k. Okay, so next one value is created, one. And now for second one, again we have to take age, and next is, suppose age group is of 27, and their salary is let's consider that their salary is 37. Now next group, let's consider next group which is having age having, consider 29, comma, they have salary. So just a minute, salary. So suppose they have a salary of 40,000. Okay, and the last age group I will consider is age having 31 years, and let's consider their salary, their salary as 42,000. Okay, so we have done with the data set. Now this is our data set which is stored in variable data set. Okay, it is not connected with the Google, that's why it is connecting. So just wait for a minute and it will get connected. Initializing, you can see it is here, initializing. Google Colab is initializing, and now it is connected. Okay, so it's processing here. One more thing, because we want to convert our data set into data frame, for that purpose only we are going to use one panda. So only I will insert one library, that is panda. So import pandas as pd. Okay, only one library, which is I'm going to use for creating my data frame. Okay, let's move it on top of this. Okay, no issue. Now it is here. I will convert my data set into data frame. So for that purpose, let's understand my data frame is ready now. Data frame is equal to data frame will get ready now. And df is equal to pd, because we have taken as pd as a panda dot, we have data frame, and pass our data set here. What it will do, it will create my data frame. So if I'm just printing my data frame, what it contains, so it contains age and salary. Okay, I hope it is clear till now. And then next, moving ahead, we want to find out, because ahead we are going to use this age and salary. So for that purpose, we are going to store age into x variable. So df dot age will going to be as a x, and df dot sal will be our y variable. Okay, let's run it. So we have now x and y variable. Next, we have to find out the mean, the average of age. So for that purpose, we are going to say mean of age, so which is x only. Mean of x is equal to, we have x dot mean, and this will give us mean of x. And next we want to find out the mean of y as well, which will be required further. But before that, we want to create one new column which will store the difference between average age and the actual age. So let's create that df, and that variable will be difference of x. I forgot to mention quotation. Yeah, single quotation is equal to. So we have difference. So for difference purpose, what we have to do is subtract both the value. Which one? The average, which is having mean of x, average minus the actual x. And let's run it. So we have now new, we can say column as a dx, d underscore x, which is having the difference of x between mean and actual x. So now we have another thing to do is we have to find out the square of difference, the square of difference. So let's again create one variable which will store the difference of x of square. These all are going to implement in further steps, so that's why I'm calculating it earlier, because our regression is going to be, linear regression is going to be used with least square regression, so that we have minimum error, okay, minimum difference. So for that purpose we are using it. So difference of dx square, which is equal to, we have to take here the dx, which we have taken d underscore x. Okay, so for that purpose we are going to take df dot, do we have now where we have df dot d underscore x. Okay, and now we have to just multiply with the 2 so that we can get the square of difference of x. Okay, now we want to find out sum of deviation of x, sum of deviation of x. So for that purpose we have formula that will just sum up the square of difference which we have. Okay, so sum of deviation of x is equal to df, which is having difference of, just we have done square, so df dot dx square. Okay, so we have difference of dx square dot sum. We just want to find out the sum of square, and this will store the sum of square. This will be used for finding the slope of linear equation. I hope you all are aware of that formula equation of line, which is known as y is equal to mx plus b, where m and m is slope and b is intercept. So for finding the slope, we are using this sum of deviation of x, which is part of list, we can say list square of list square regression, which is part of list square regression. Now we have the sum of square, and next we have to find out, also we have forgot to find out the mean of y value. So for that purpose we can see mean of y is equal to y we have value and dot mean and function. So by this way we can find out the mean of y value. So mean is ready with us. Now we have the same as we have done to finding the difference of x. We are going to find out the difference of y. So I'm just doing copy and paste here for the same code. It is going to be y here. It is going to be y here also. And because it is difference of y, so we are going to write it as difference of y. So we have difference of y as well. Now, next step says we have to find out deviation between x and y. Okay, so sum of deviation of x and y. So for that purpose, we have formula. So for finding sum of deviation of x, y, previously it was x, and now it is x, y, is equal to, we have multiplication of both the differences x and xx and xy. So for that purpose, we are going to call df dot difference of, we have x. So let's take that x, difference of x into difference of, so difference of y. Okay, difference of x. So of course we require df dot here. So difference of x into difference of y dot, we have to do here summation. So we will just sum up this. Okay. Okay. So now for slope, we have formula sum of deviation of xy divided by sum of deviation of x. And if you want to see what actually df contains, so we can print df here, and we want to see what m containing, then we can see what m is having with us. So for m, just print m. You will come to the slope value. So actually slope value is 1.2. Now the time is to find the intercept. So for intercept, we know it is y is equal to mx plus b. So b is this, b is equal to, we have formula for intercept, that is average of salary here, that is average of y, which is mean of y we have here. Okay, and then subtract the slope, which is having m here, and then multiply slope value with the average of age, which is having x. So m of x. Now z, it's x. So we are having now intercept value as well. Okay, so intercept is 4.899 something. So this is our intercept value. Now we are ready to predict, we are ready to perform the linear regression, which our formula slope into independent value, okay, plus intercept, which will give us the dependent value, predicted dependent value, that's predicted value. Okay, so for that purpose we have a formula, but here because we are not using any type of formula, so we have to I have used here some simple for loop to predicting the value. So formula, let's begin with finding predicting the value. So for that prediction I need one list, because I want to store my value into list. So for list, I will give that name as a salary prediction. So salary prediction as a list, predict salary pred as a list name. And then I will use here my for loop, which will take the value from the, above, and we can say y and x, and then we can create sorry, it will take the value from the X, and then we can perform the linear regression. So a salary predicted for loop I have, and then for I, because it is going to take, I am taking as a variable, which will read from in df dot, or we can say df, where which is having which variable. So here specifically I'm talking about age. Okay, it will read from all the values from the age. What we want to do, so we want it that list which we have created just now, I have created just now, grade dot append, and append what? So here we are, I'm going to put the linear regression formula, which says slope into the independent value, which is X, plus we are going to add this intercept. So it's a P, and this will predict my salary. So if I want to see salary predicted, it is somewhat this. So if you match this salary 35 for 25, it is 34.9. It is somewhat exactly we are nearest to this. 30, here it is 37, it is 37.3, it is 39, it is 39.69, it is 40, and here you can see 42, it's a 42 only. So somewhat we are getting approximately nearest to the actual value. If you'll observe both the value, you can say that your predicted value is nearest to the actual salary value. Okay, now one more thing I want to do is I want to find out the difference, because I want to find out the residual sum of square, and for that purpose I'm going to take out the difference between the actual predicted and actual and predicted. So for that purpose I'm again going to use one of the list, which will say difference of y pred y and predicted y. Okay, and this is the list, and I'm using for loop for. Now we have two things, salary and salary predicted. So for that purpose, I'm going to use one container here. Okay, so before performing for loop, I need that container to put. So suppose that container is, we can give it as a name, y h y pred. This is the container which is storing the value. A zip is the method which act as a container, and it is storing both the values separately from the data frame. So this is df dot. If I use df dot, or I can directly use in bracket, which is having the value of salary first. Okay, and here I can use directly which is salary predicted, which list I have created. Okay, salary predicted. This too is there in container, and now I will use for loop for taking this out. So for I j, I'm using two variable because it have to fetch from two column. I j n y actual y predicted. What I want to perform this, so I want it to store in d difference of y and predicted, append. What append? Append the differences between these two, right? I and j. So I just want I minus j. What this will do, this will find the difference and store here. If I want to print this, if you want to see this, just print it, you will get the difference. See, it has calculated now the difference between predicted and actual. So once we have done with this finding the difference, now we just need to find out the square of h. Okay, so for that purpose, again, I'm going to use the same thing. So let's write it as a list name as a square of predicted value. Sorry, square of difference value. This is the list, and now I use for loop. Okay, for I in, sorry, for I in. So we have difference of y and we have predicted. Okay, this is our list from where I want to find out the square. So we have a list where it is having square of difference dot append. What append it will do? It will just square. So I, whatever I value is, it has to be squared. Sorry. Oh, it has to be squared. That's it. If you want to see squared value, so square difference you can print here, you will come to know. These are the squared value. Now I want to find out the residual. So for residual of sum squared, so RSS, it's a residual of sum square is equal to sum of what that we have calculated as the difference. Okay, square of differences. So sum of this variable SQR differences. And now you can print this RSS. So we have residual of 0.2. Okay, 0.2, and this is having the approximate prediction is nearest to this approx value, actual value. So I hope you will like it, and if you like it, if you need code or if you need any assistance, if you want anything, just comment below and I will let you know. Thank you for watching my video.